Next up is Doug Sauer, who is the manager of Midstream Logistics for Phillips 66. And I'll let him tell us what he's going to talk about, but I think he's going to talk a lot about the recent API recommended practice on leak detection.
Okay, good morning everybody, and thank you, Carl. Again, my name is Doug Sauer. I'm with Phillips 66. I'm in the liquids pipeline industry, so I'm going to talk to you about leak detection from a liquid operator's perspective and explore the question of what is the right approach. The best defense against pipeline leaks is to prevent leaks from happening in the first place. Our industry has several proactive programs in place for several years. Pipeline integrity inspection programs, for example, damage prevention programs is another one, which have successfully been in place to reduce the number of pipeline leaks. But my presentation is going to focus on the industry efforts of detecting leaks after they occur. And one thing to mention is, we've heard it earlier, I think, is that one size does not fit all situations. There's various pipeline systems, various operating conditions can call for different approaches to leak detection. We heard earlier this morning from John Studi from AOPL around the progress and, with leak performance. So the number of large pipeline spills has decreased, which is very good progress. But we also know that spills have still occurred, right? So as an industry, we're focusing on zero incidents. And we recognize more work is needed, and additional technologies like some of which we just heard can definitely help us in that direction. So if you break down leaks by sort of categories, I'll start with ruptures. These are leaks where we would expect an early detection of these types of leaks. Tools in place that operators use are pressure and flow deviations that can alarm and tell a pipeline operator in a control center of an abnormal operating condition. Also, there's a software system that is called computational pipeline monitoring, and that's a continuous monitoring both software and hardware, so I'll call it a system that will allow operators to detect leaks, and I'll get into a little bit more of that later. The category of seepers, we've heard a little bit about seepers. You typically have a slower detection on seepers. Some techniques used for detecting seepers: visual surveillance, whether it's from air or from ground surveillance, that's used. Also within facilities, we can have gas vapor monitors to detect hydrocarbons. There's also some newer technologies that are using thermal imaging to detect a change in temperature that may indicate an abnormal situation at that facility. And then pipeline volume balancing, and then static tightness test, essentially to assess whether the pressure is holding in a pipeline. And then we have the category of everything in between, between seepers and ruptures. Again, computational pipeline monitoring software. The acronym for that is CPM, so I'll just for the sake of convenience, I'll probably just refer to those as CPM systems. Those are used pretty extensively across the pipeline industry for detecting leaks kind of in that wide range of size. There's pressure wave and statistical pattern recognition that is used. Again, looking for, it takes a lot of programming and setup to essentially establish what normal conditions are, and then it can alarm whenever you're outside of those normal ranges. But very important to that and very time consuming is to get those tuned correctly so that you don't have a lot of false positive alarms that can be problematic. Fiber optic cabling technology is one we just heard about, so I won't get into much there. Not very widely applied on existing pipeline systems today, but the liquids industry is funding research right now with the Pipeline Research Council and some joint industry programs to try to advance that technology. So there's a number of challenges with these new technologies, but I'm certainly excited about what lies ahead and what may be possible with these technology developments, because these can certainly help us advance our ability to detect leaks as an industry. Let me kind of pose this question. So why, we often get the question, why doesn't or why can't the industry detect leaks immediately? Well, it's a fair question. And not an easy answer, but I'll explain a few of the, and I'll actually go back, this may help with this if you look at the blue box under complicating factors, but I'll explain a few of the factors that do add some complication or some challenge to detecting in a real timely manner. Compressibility of the various fluids that we move through our pipeline systems, they behave differently. Elevation differences along the pipeline. Sometimes we're pumping uphill, sometimes we're pumping downhill or over hills. That can change the pressure profile, adding some complexity to be able to recognize an abnormal condition. Dynamic operating conditions, so we're starting and stopping pumps along the way. We're making deliveries along midpoints of the pipeline systems. We're increasing flow rates, we're decreasing flow rates. All of these are normal conditions, but when you think about trying to recognize an abnormality, it adds a complication. And then I'll mention low pressure. So one of the things that's a very helpful tool is pressure and flow deviations. So we can set these kind of triggers in the control centers to recognize when a pressure, for example, drops suddenly, that's outside of the expected range. We can get an alarm. The controller can then investigate and take action. When you have a pipeline that normally operates at a very low pressure, which we have a number of those across the system, again, it depends on the conditions, then your margin of pressure change is a much smaller margin, right? So hence you're not getting that rapid pressure drop with a leak on a very low pressure system. Adds a bit of complication to be able to detect quickly. So just to mention that's just to explain that there's a variety of conditions, and because of that, we need to look at a multi-layered approach when it comes to leak detection and really try to select the right method for the right situation to be able to detect when there's abnormalities. So I won't spend a lot of time on this curve, but the engineer in me would love to spend some time talking about this with you. But essentially, I'll just let you know that this is a curve, a performance curve of a typical CPM system, these computational pipeline modeling systems for a control center. And so it's on the vertical axis, you have the leak size. On the horizontal axis, we have leak duration. But I think the overall message here is that as an industry, it's not only the technology, but it's the people, the processes. We need very capable people in the control centers, and so being able to detect a leak certainly depends upon technology, but then there's that ability to interpret what the information is telling us and be able to make decisions in a timely manner if you've got an abnormal condition. And that's where our new leak detection program management standard, or RP 1175 is what it's called, comes into play. The last thing I'll mention on this slide is that when it comes to CPM systems, there's sometimes a misconception about whether CPM systems work. We see statistics or we see data that says, only 20% of the time a control center recognizes a leak. Okay, that doesn't sound very impressive, but if that's the entire leak portfolio or the population of leaks, you've got to understand that 2/3 of those leaks are leaks smaller than 5 barrels, and CPM systems are not intended to detect those small leaks. So of the leak category where CPM systems are well suited, the medium to larger leaks, the performance of CPM is really more in the 70 to 80% effectiveness. So effective leak detection, it's more than having great technology. Technology also needs strong control center operations. For example, I've talked a little bit about it already, but recognizing abnormal conditions. It's not always obvious. It takes a strong operating qualification program. It's a strong procedures, strong processes in our business. Secondly, we need to have the right kind of culture in our business when it comes to leak detections. We need what I call a think leak safety culture, and that would say that we, for example, not necessarily waiting until you have 100% confirmation that there's a leak, there's product on the ground leaving your pipeline system. Rather, it's acting when you have enough information to see that there's abnormal conditions and go ahead and that possibly indicate a leak and taking the appropriate action, investigating, shutting down. If we confirm that it wasn't a leak, no harm, we'll resume operations whenever it's safe to do so. And that's a fairly common practice, is reacting proactively to take pipeline systems down when there's enough information that indicates a potential problem. Many times it's just an equipment malfunction. We get that addressed, assess the situations are normal, then we'll resume operations. I think the bottom line is that pipeline operators need effective leak detection programs. It's not only about the technology, and all of these issues are covered in a new API recommended practice called 1175. This is my one and only slide on API 1175, the leak detection program management. If you attended this conference last year, there was a presentation on the 1175 RP, and I think it went into quite a bit of detail as to what the contents are, what it's all about. So I don't plan to go through that again, but I will just summarize it for those that aren't familiar with it. It's a recommended practice, identifies, it includes all leak detection methods, policies, procedures, and the human element, right, within our operations. It's so critical. That RP was developed last year. It was published at the end of the year, some 10 months ago. And it includes a number of these things around, as I mentioned, culture. And this culture, it's not just a safety culture, but it's about having a leak detection culture, right, in our business. So we're now into the next phase of that, and this is implementation. So in 2016, earlier this year, API and AOPL formed an industry team to help operators implement stronger leak detection programs. I'm leading this team. We have representatives from a variety of pipeline operators. In fact, I just came from one of our planning meetings earlier this week where we worked on a number of things. We're planning a webinar to be held next month. We're planning an in-person workshop that will be held in conjunction with the annual pipeline conference. That's in April of next year. That one will be in San Antonio, Texas. So our leak detection workshop is planned to be held immediately after the main conference. And then we're also developing training and assessment tools. One of the assessment tools that we are finalizing and going to be sharing with the industry is what we call a gap assessment tool. So we want the operators to be able to measure their current leak detection program capabilities and whatever maturity level that's in, compare it against the new RP, which is a compilation of best practices, and there will be gaps. And we want them to understand those gaps, measure those gaps in all the different areas, and then they can use that to build action plans and build their strategy around how to improve their business when it comes to leak detection program management. And I feel like getting this 1175 implemented out in the industry will be a home run for us. I think that it should drive significant improvements across our pipeline industry. So last slide, let me close out with just to summarize what I think are the keys to success for effective leak detection. First, having a continuous improvement mindset towards technology, of course, but also towards people and procedures. And that includes endorsing a couple of new recent APRPs, and that's 1173 safety management systems. We heard a little bit about it this morning. There's another presentation that you'll hear about tomorrow on safety management systems. And then secondly, the leak detection program management, RP that I'm leading right now, 1175. The second key is again, in summary, to have a think leak safety culture. That takes leadership support in the businesses. It also takes a rigor around training and operating discipline. And thirdly, it's working together across the industry, having a collaborative and a proactive approach. We want to share best practices about different methods that operators are deploying that are successful, sharing lessons learned about accidents, near misses, so we can learn from those as well. And then, of course, jointly pursuing new technology research. All of those, I believe, are the keys to success. So with that said, I think that most of us probably align that we have a shared mission when it comes to this. Obviously, our mission is providing reliable energy supply to meet society's needs. And we certainly need to do that in the safest and environmentally responsible manner possible. That concludes my presentation. Again, thank you all for your time.